Hello everyone and welcome to today's Help Systems webinar when JDBC and ODBC jobs attack, coming to you from beautiful Eden Prairie as well as Rochester, Minnesota here in the USA. Thanks for joining us. Oh, how we love QZDASOINIT jobs, don't we? Those JDBC and ODBC requests to the database help enable the open database world that we live in and actually have lived in for quite some time, but as we all know, poorly written SQL statements, massive file joins, or requests that just multiply in front of your eyes can really bring your IBM I system to its knees and leave your end users twiddling their thumb and reaching for their phone and potentially sending a nasty gram to your inbox. So don't wait for that email. Let's all be proactive about our monitoring and identify these processes, and we've got some tools today that might help you with that. My name is Chuck Lisinski and I am the Director of Technical Solutions here at Help Systems, celebrating my 20th year with Help Systems, 30 years on IBM I, and today I'm joined by Terry Preston from our support team, Principal Senior Support Analyst with Help Systems and well experienced with Robot Monitor. Hi Terry.
Hey, Chuck. Congratulations on 20 years.
Thank you.
I'm 25 this year.
Fantastic. So you've got probably 60 years on IBM I total in front of your eyes. So that's pretty crazy. And I know we got a lot of experienced people out there as well. Terry's, as mentioned, is on our support line. She helps support Robot Monitor, and that's why she's here. She's here to answer your questions. She's going to be monitoring the Q&A during today's presentation. If you do have any questions, please feel free to send those in to us and we will answer them during the presentation, or if we have to, we'll certainly follow up after. So today the primary topic is going to be around this tool in our robot product line called Robot Monitor. This tool has been part of the robot product line for about 5 years. Prior to that, it was in a different form, had a different name. It's been out there helping support IBM I administrators and operators like you folks for 25 years. And the product was designed to be a multimodal monitoring tool. So it can monitor more than just the ODBC, JDBC functions going on in your system. You can slice and dice your monitoring as needed. This product is highly configurable and has some built-in monitoring capabilities for multiple workloads such as PowerHA, BRMS, Mimics, batch workloads, and so forth. And it's a real-time monitor. We monitor every 30 seconds on your system. You can adjust that as needed. And then we also take the data and summarize it. And this is also a multi-system monitoring tool, meaning I can monitor multiple partitions, including IBM I and VIOS. VIOS obviously has gotten very important to us, especially as we move into the Power 8, Power 9 world and the virtualized world. So a lot of capability here. We'd be more than happy to give you a one-on-one demo at some point, but today we're going to focus primarily on the JDBC, ODBC connection and SQL requests, internal and external. So the tool itself, the Robot Monitor tool, is very graphical. As mentioned, it does have external notification as well. So when you do hit some kind of a threshold, be it storage or CPU utilization, disk I/O, etc., we will be sending out notification. But this just shows you, for instance, a dashboard that I created. I actually just got this screenshot about an hour ago off Robot Monitor, and you can see on the right-hand side, I've got 6 systems included in this dashboard. This dashboard includes both IBM I and an AIX partition or VIOS partition. All right, so highly customizable depending on what your needs are. In terms of the overall architecture of Robot Monitor is a native monitoring tool, meaning all the programs are running locally on your system. There's nothing external other than the graphical user interface. The graphical user interface is installed on a Windows desktop, and then one of your IBM I partitions is the central data collection point for the monitoring of all your other partitions. So there's native monitoring tools that are collecting data from all of your systems, IBMI, AIX, and VIOS, sending that data to your central system. That's where the Robot Monitor GUI will connect to, so you can visualize that and you can set up things like thresholds. And then if any thresholds are exceeded, we have multiple ways of sending out notification. We can put a message in a message queue. We can interface directly to Robot Alert if you already have that. In your infrastructure, we can also escalate up into Robot Network if that's part of your infrastructure as well. Okay, so that's just a quick intro to Robot Monitor in terms of the architecture and some of the functionality. But we're going to start with a quick polling question. And the polling question is about where do you struggle with job monitoring? All right, so I've launched that polling question. Please take just a moment and answer the question. It's a checkbox question, so you can answer or you can make multiple selections. The question is, where do you struggle? And the answers are no monitoring for user queries, no visibility into problematic SQL statements, no notification for jobs consuming too much CPU, no way to report on job or subsystem performance, no easy remediation for problematic jobs. Those are all things that we're going to talk about today in Robot Monitor. I've been using Robot Monitor for about 5 years now, and highly impressed with its real-time capability and customizable capabilities. Also, the built-in reporting that we'll talk about toward the end of the presentation today comes from the graphical interface. And the reports can be scheduled. I could schedule them with a Windows task scheduler, or if you have something like Robot Schedule Enterprise. Basically, it's a PC command that you'll execute to run those historical reports. So if on the first of the month you need to report on what happened in the previous month, that's what you'll be able to do. All right, give you about 5 more seconds to answer that question. And let's close and share. And Terry, I'm going to let you talk to the results a little bit.
Oh, okay.
Okay, what do we have for results?
Well, it seems like the biggest problem is no monitoring for user queries or external apps, which I'm not surprised because there's not a lot of things out there that can do that. And no visibility for problematic SQL statements, I can totally understand that too. Oh, this is one that's easily solvable for us. Notifications on jobs consuming too much CPU. I think you're going to talk about that.
All right.
Right, Chuck? And the same way on reporting for jobs or subsystems performance. So,
awesome.
Yeah, I think you got your work cut out for you there.
Yeah, and actually the rest of the webinar is going to be pretty fast-paced. We've got a lot to share, so let's hide that.
Mm-hmm.
And let's dive into our agenda. So this is what our agenda looks like. First of all, we're just going to spend a minute talking about the remote database connection itself. Then we'll dive into real-time monitoring. We're going to talk about batch job monitoring too, because you know what, you've got a lot of either legacy code or modernized code running on your system, and there's a number of embedded SQL requests, no doubt, in those. We're going to talk about something called Hinder jobs. That's a function that's in Robot Monitor that allows you to throttle back offending jobs. We'll talk about historical reporting, and of course, we're going to leave some time for Q&A at the end as well. So let's talk about the remote database connection specifically that we're going to focus on today. We're going to talk about ODBC connections and JDBC connections primarily. You guys are very familiar with these in the form of the infamous QZDASOINIT job name that typically shows up in Q user work subsystem. If you're familiar with subsystem technologies, or if you're not, if you're fairly new to IBMI, we can certainly get you up to speed on some of the work management built into the operating system as well. So with Robot Monitor, we can focus on those activities specifically named QZDASOINIT. We can also focus on activities by user profile name. We can also focus on other connections, other remote database connections like DDM, DRDA. We've got products, GUI products that connect via that way as well, that protocol. And you may see some requests or some jobs on your system, QSQSRVR. And if you do see that, that's some additional programming that was required behind the scenes. Those jobs are in the form of a pre-start job. And again, that's part of a JDBC, or could be part of a JDBC connection. So how do we go about monitoring that activity in real time? And what do we want to monitor? All right, so what you're looking at right now is a pretty complete list of everything that Robot Monitor can watch on IBM I. Okay, so there's quite a bit there, but we're going to focus on CPU usage, disk I/O, faults per second, job count, QTemp, and temp storage when it comes to those QZDASOINIT JDBC connections. Okay, so how do we tell Robot Monitor to watch just that particular workload? Okay, now first of all, Robot Monitor can watch overall CPU usage. That's one of our built-in turnkey monitors along with auxiliary storage and everything you see here in the built-in list. But now you can focus on workloads. In fact, you'll see a plus sign by all these various monitors, and that means that the monitor can be customized to your needs. All right, so you're looking right now at the Robot Monitor graphical interface, a desktop view. And we've drilled into CPU usage, and you'll see behind the scenes here, we've got a number of workloads, specific workloads that we're monitoring just for CPU, just to keep it simple at the moment. So to define a CPU usage monitor just for QZDASOINIT, I can go into the monitor and I can right click on it and it will show me all the job activity on the system, or I can just type in the job name QZDASOINIT. There's a number of other parameters, like I could use subsystem name, username, current user, job name, function, and then I choose what systems I want to monitor that activity across. Okay, by default it's all systems that are part of your Robot Monitor network. Otherwise you can be specific. All right, so I've set up the monitor. The next thing I'm going to do is I'm going to set up thresholds. Okay, so the thresholds can be global thresholds. They can also be customized thresholds. Global threshold means that anywhere that I set up a particular CPU usage threshold, that's what's going to be used no matter what the workload. I can customize that. All right, so I've set up a 50% threshold, and within that 50% threshold, I've told it to send a message to a specific message queue on the system. I've also said I want you to talk to Robot Alert directly. So if you're familiar with Robot Alert, that's our conduit to the outside world from all of our robot products, and that's what sends out things like email and text. All right. So with that, if I do get notification, first of all, in terms of a message queue, there's a message queue dedicated to Robot Monitor called MonTHR on the central Robot Monitor host. All right, we can also send to a message queue on the local system as well. But you'll see we've got some job and CPU messages that are going out there. It's a specific message ID that you can intercept with a product like Robot Console and escalate. We can talk directly to Alert. All right, and also now we have Robot Console in our Insight web interface. So now we can see those messages there as well. Okay, so let's go through a quick scenario. So you get a text message or an email on your mobile device, iPhone or Android, saying that you've hit some kind of a JDBC threshold on the system, 136%. And so you, back at your desk, you drill into the Robot Monitor GUI and you can see that my JDBC CPU that we had previously defined as a monitor type is red. Color coding is very important in Robot Monitor. We're able to drill into this vertical real-time bar that's showing what's happening right now in my system to see what constitutes that workload. As you can see, Chuck has executed a JDBC request, and from there I can work with that job and I can see the SQL statement. I can see the address where that request is coming in from. I also have the ability to make changes to the job. I could put it on hold. I could end it. I could look at the job log. And also we've, as of April of this year, we've added a new view into Robot Monitor that is specifically looking at CPU users using SQL. And that's kept historically. So I can go back in time and see for any time period what jobs were consuming CPU, and that's kept for, a period of time, usually 30, 60, 90 days. And beyond that, we'll have some summary data. Okay, so let's do a live demo.
Okay, let's take a look at Robot Monitor live. So what you're looking at is the Robot Monitor graphical interface, and you're looking at a dashboard called Production. And in that dashboard, I have 3 systems displayed: my Academy, my Gwynvere, and my Wisdom system. I'm collecting overall CPU usage, batch CPU usage, disk percent, or auxiliary storage, and even just to show you some of the variety of things that can be collected with Robot Monitor. You'll see here I've got a number of spool files in the QEZ job log out queue. All right. Likewise, uptime. Here's my JDBC CPU monitor. I showed you that in the presentation, how to configure that from a CPU monitoring standpoint, and even the size of QHIST files. Specifically, what we're going to do now is we're going to trigger a JDBC event. All right, so we've got our monitor set up for that, and we're going to see what that looks like. We're also going to get some notification, and we're going to focus in on one particular system called Wisdom. It's an IBM partition. And first of all, as you can see, we've got a number of monitors already set up. A couple of them related to JDBC, like JDBC CPU utilization, faulting, QTemp size, temporary storage, even number of JDBC jobs. Now, one of the things you can do with the graphical interface is you can create a hierarchy for the visual monitoring. Okay, so I created a separate group or list of monitors just focused on QZDA. And in fact, I've duplicated, for instance, the JDBC CPU utilization in 2 places, okay, both on my primary visual screen as well as this group. So what I'm going to do is I'm going to trigger a JDBC event. So I have an ACS, Access Client Solutions SQL script that I'm going to run, and that's going to show up as a JDBC connection. So let's go ahead and run that. All right, so that's talking to my Wisdom system. All right, so I'm going to move that back off to the side. And you're going to see that reflected in the real-time monitoring of a Robot Monitor. All right, so we should see the CPU utilization go up. We'll probably see the disk I/O go up as well. All right, so you can see that happening. All right, so what I can do is I can drill in a couple different ways, but let's go this way. All right, you can see there's my connection, and I can work with the job. And what that's doing is it's bringing back the work job information. So for instance, I can see the SQL command. I can see the IP address. All right, I can take action on the job. I could change it, hold it, release it. I could drill into the job log. All right, I can get to things like open files, call stack, and so forth. All right, and that process has ended. So if I go back to my Wisdom system, we'll see the CPU utilization begin to drop. All right, remember we're collecting every 30 seconds, so initially it's gone up, and then it's going to go back down. All right. Another way I can drill into that is through what we call short-term history. So you can see some spikes in my CPU utilization for QZDASOINIT type activity. All right, so I could drill in here, I could drill in here on the graphical interface, and from here I can simply double click and drill in. Now what I'm looking at is all my activity on the system that is consuming CPU for that particular time period. And I can go backwards in time. All right, and I can go forwards in time. Every 30 seconds we're collecting the top 10 jobs that are consuming CPU or consuming disk I/O. And then we have a new view that is showing the high CPU users using SQL. All right, so that's just a quick demonstration of JDBC monitoring using a Robot Monitor. Let's go back and talk batch job monitoring.
Batch job monitoring is another area that we need to focus on because SQL requests can also be coming in from your RPG programs running on your system. Certainly you can have embedded SQL in your RPG requests. So just a quick example. Here I've got an MRP batch job running on my system, and I've set up a group of monitors monitoring batch CPU, batch jobs held, batch jobs on out queue, whether or not my batch job queue is available or not. As you've seen, I've got a threshold set up on my CPU utilization watching this activity. My MRP has now hit a certain amount of CPU utilization on the system, so now we need to work with that. Okay, so what does that look like? Looks like this. So I've set up a group of monitors to watch for not just CPU utilization, but also job queue status. Okay, so you can see my job queue says it's held. Okay, so I got notification on that. Within the GUI, all you have to do is hover on the GUI and you'll see whether or not the job queue is held. Job queues are jobs waiting to run. Look at that, 322 jobs waiting to run. So that's overall, all the batch jobs on my system waiting to run. Here's max job wait time on job queue, 29 minutes. So I've had jobs waiting on job queue for up to 29 minutes. Again, I'm kicking off a threshold, 29 minute, or I'm kicking off a threshold. At some point, I can set different thresholds, but that's a long time to be waiting on the job queue. All right, and I've also got some jobs that have been out there running for quite a long time. Okay, so that could be another factor that we need to look at. So drilling into my CPU utilization, as mentioned, we're collecting the top SQL CPU utilization jobs as well as the overall CPU utilization for the top X number of jobs running on my system. By default, we're collecting the top 5 jobs. I've got mine changed to the top 10 jobs. So every 30 seconds, we know exactly what jobs are running at that time period, and we can go back in time. So for instance, I could go back an hour, I could go back 15 minutes, I could go back 5 minutes, or I could go back a week or 2 weeks or even a month into that detailed data to find out exactly what was running. Okay, and it's simply a drill down process. All right, so we're going to dive into a live demo here for batch job monitoring. Okay, we're going to be working with my Wisdom system. All right, and just like my QZDASOINIT monitoring, I've set up a specific group of monitors around batch jobs. All right, so just hovering, here's my CPU for subsystem QBatch. All right, so once again, that is a CPU usage monitor set up just to watch what's going on in my QBatch subsystem, and I've focused that on my Academy and Wisdom systems. All right, so let's submit a batch job that I know is going to be consuming some CPU on my Wisdom system, and it's actually going to be running an embedded SQL request, and we're going to be able to once again drill into that. So some of the other things that I'm monitoring here, okay, I've got one job that's held on a job queue. I've got 18 jobs waiting to run. All right, looks like my QBatch job queue is active. However, looks like I've got 6 jobs on my nightly job queue that are waiting to run, and guess what? The nightly job queue is held. All right, so that's not so good. So that's something that we should probably investigate. All right, so I've submitted that batch job. As you can see, we're now at 178% CPU utilization. So what I can do is I can drill into that, and I can see exactly what activity. You see, it's kind of an ugly SQL. That's the job name. All right, so we're going to drill into that, and we're going to look at the SQL information. So we can drill directly into the SQL statement. Notice there's no IP address involved here because this is coming internally. All right. So likewise, if I just look at this in terms of overall CPU utilization, you can see we've had some spikes. All right, so what I can do is I can drill into any one of those spikes and I can see exactly all the activity that's running at that time period, and I can go backwards in time. So you can see down here we've got arrows that go left and right that can walk you through those 30-second time periods to show you exactly what was running at that time. Okay, next topic. What can we do about this activity? There is an option called Hinder jobs in Robot Monitor. Okay, and that's a little bit of an English terminology, but basically it's a command that you can embed into a Robot Monitor monitor, and the monitor type is check job, CPU, and Hinder. And basically what it says is if I have a job that's exceeding a certain amount of CPU utilization, I want you to throttle it back. I could put the job on hold. I could change the run priority, and that's actually what we're going to do is we're going to lower the run priority, and we're going to lower it by a certain amount for every 30-second iteration until it starts behaving. Okay, we can tell it how many samples to take. Okay, we're saying 3 samples. Those are 3 30-second samples, and then we're going to take action. I could do it on a batch activity. I could do it on QZDASOINIT activity. You can focus it on certain subsystems. All right, I'm doing it across the board for all my QZD activity. You can see you can use wildcards as well. Okay, quick demonstration of this looks like this. So let's dive into our QZDASOINIT group, and right here is my QZD Hinder monitor. So I'm going to drill into this, and here's my moncheck JCP job. Or command. I'm going to prompt that, and it's showing me at what point we're going to initiate the throttling back of that activity. So once we hit overall system CPU usage of 90%, we are going to look at my QZDA jobs that are running in queues or work, and we're going to lower the run priority. Okay. Now I also have this same monitor type set up in my batch activity, and you can see that my check job CPU and Hinder says we've got one job being throttled back right now. All right, and that's that ugly SQL batch job. And notice the run priority is 99. The run priority started out as 50, but Robot Monitor's actually throttled it back now automatically. So we've lowered the run priority, so it should be impacting our system less than it was when it first started out. Okay, and the last topic is historical reporting. All right, and so in terms of historical reporting, let's drill into our JDBC CPU data. So this is what's been happening over the past 8 hours or so. Robot Monitor will automatically summarize this history. All right, so I can look at just my QZDASOINIT JDBC activity. Now I'm looking at summarized activity over the last 12 months. So here's my averages going back to September of last year, 2.85% to a high of 5.74%. All right, so this graphical reporting, I can do a print option and just print the graph. I also have automated reports built in that will email me, and I can automate that process completely, reporting on, for instance, a previous month. I can also drill into this activity. So what you're seeing right now is the daily summarized information being downloaded from the IBM database. And by the way, the data is stored very efficiently. We compact the data as we put it into the DB2 database. We use variable length fields, so we can compact on the way in. So let's say we're going to look at, let's say, Monday, July 29th. You can see we had a spike here about 1 o'clock in the afternoon. Now I'm going to drill into that. Now we're pulling in the detailed data, and look at these spikes that occurred kind of mid-afternoon. Let's drill into that. And sure enough, looks like we had some QZDASOINIT activity by that user Chuck back on July 29th at 1:45. So if you have a complaint that your system was slow or that there was something going on at some point overnight or yesterday, you can go back in time and look at that information. All right, so that was a quick review of Robot Monitor. And we're going to throw out another polling question. Polling question is, how can we help you? And while we're spending some time answering that, Terry, do we have any questions to follow up on?
Well, we have just a couple of questions here. The first one, does Robot Monitor take up a lot of space to store its data? And I think you already addressed that we're very efficient, but you can run the Mon purge to control that. Any other purging ideas, Chuck?
Well, purging obviously is important to have in place. Also, you can obviously change the amount of detailed data that you want to keep. I'm keeping 30 days of detailed data. Some folks keep up to 90 days or even a little bit more. So, you can change what you want to keep depending on what your needs are. 30 days seems to be fairly adequate.
Yeah, in most cases, that's what I recommend also. Another one, and this is one I get a lot, does Robot Monitor use collection services? So are we out there using the IBM collection services?
Yeah, and 99.9% of our monitors use IBM I APIs, and any way we can collect the data as efficiently and quickly as possible. So primarily we do not use IBM collection services, just on a couple of monitors.
Correct, yeah, and remember ours are 30-second collections, so it's going to be very quick.
Yeah. Anything else?
Okay, one final one. Does Robot Monitor use a lot of CPU cycles?
Well, once again, we've designed our monitors over the past 25 years to be as efficient as possible. Certainly they will use a couple CPU cycles, and as you develop more and more monitors, of course, you'll see a few more cycles being used, but I tell you what, I've got hundreds of monitors running on my system, and we don't see much for a CPU blip at all. And what's really neat about Robot Monitor is you can have monitor itself. Have monitor watch the amount of CPU that it's using. You can also have it watch the amount of DASD or disk space that it's using to store its data. All right. So that's all the time we've got, Terry. If we do have any other questions to follow up on, we will follow up after the fact. And we are just past the bottom of the hour, so really appreciate your attention today and hope you got something out of our webinar. Hope to see you in a future event from Help Systems. Everybody have a great day. Bye-bye. Thanks, Terry.
Thank you. Bye-bye.